All right, now I'm going to show you guys something cool because this is not bash specific. This exists on your operating system and other programming languages can use this, but we can use something called a named pipe. Now, you know, in bash, we have a basic pipe like cat, pipe, grep, and here's the pipe here. This only exists between these two processes. We can make a pipe that's like a file. It sits on your file system and technically any process can write to it. So I could have communication between like a process written in C and a process written in bash. I could have the C program writing to it and the bash process consuming it, which is pretty neat. So I'm going to show how we can do that here by making a pipe. So let's go ahead and make a pipe. Make FIFO. First in, first out. We'll make FIFO. We'll call it pipe. This is just the name of the file, so we could put / here. And now we have a file here called pipe. And pipe is pretty cool. It's very, very simple. Let's go ahead and do something very rare. I haven't done this yet. I'm going to pull up a tmux just so I can split this terminal so you can see both of what's going on. I don't have a session, so let me create a new session. Let me split this pane. Do I want it vertically or horizontally? I think I want it horizontally. There we go. Okay, so now I have tmux here, so I have two different terminals running, and you can see each one here. Here's the cool thing. I can echo hello and put it into pipe, and it just hangs. It just hangs until something comes and reads it. So I can go down here, and I can read that pipe. Ready? When I hit enter, watch what's going to happen. Both of the prompts return. I get the data down here, and this echo is done hanging. So pipes are really cool. The opposite is also true. If I cat pipe, it will hang until something writes to it. So if I go up here and I echo into it, echo returns immediately. The cat finally hangs. This is why pipes are so useful, because they will block until something else is talked, so you can synchronize communication between the two things, which is really nice. And of course, you could have external processes reading and writing a pipe, or you could have the same process talking to itself over a pipe. You may want that for some reasons, depending on what's going on here, or something else can tap into that pipe and see what's going on. It's really cool. All right, so let's see what we have here. We have a script called basic reader. Basic reader is very, very simple. Look at this. We just do a while read line, we read in from pipe, and then we print read line and then the line that we read in. There's no trickery here, I promise. We're just going to run this, and this is going to hang. It's going to hang until something writes into the pipe. So let's echo hello into the pipe down here, and watch what happens. It prints hello up top. We got that message successfully. But you notice it just exited. So it read it once, and that was it. So if we want to read forever, how can we do it? Well, get ready for the cheapest solution ever. Put the whole thing in a while true loop. I mean, it works. You can totally do this. I'll show you other ways to do this later in later examples. But for now, this totally works. So we'll run that forever reader, which looks like this. We'll run the 01 forever reader, and then we can go down here and we can pipe data into it. We can continually pipe data into it. We could run a command and put it into the pipe. We could do anything, really. We could printf. Remember how we learned how to use printf? Hello, and then pipe that into pipe and get nothing? What happened there? Oh. Wow, okay. I'm actually glad I messed this up. I'm really glad I messed this up because this is a good learning experience. Do you know what's happening here? The above example is waiting for a line. It's reading a line. I have not omitted a new line yet. So let's go ahead and omit a new line. Let's just echo a new line into the pipe. There we go. Now it read all that garbage there. Did it lose all that stuff? I don't actually know what happened there. There we go. This is what I expected. I'm gonna be honest, I don't know how we lost that data. I'll have to do more digging into this. But yeah, so this is the beautiful thing. We can just kind of read until we see a new line, and we can get that data up on top. We technically don't have to read to a new line. We can just read until data is put there. There is a max size of how much you can write to a buffer at one time, so be careful of that. You will bump into some sort of limits there. But this is the cool thing. This thing will forever read up here. Let's back out of here and let's see what we have. We have the forever read. Let's go ahead and start that and just let that keep running. And then we'll go down here and we'll look at the client writer. So this is an interesting script. We start the script, we give it a name, and then it sleeps for 3 seconds, and it says client name, and then it writes to the pipe. So let's see what that looks like. Let's give it a name of foo. Okay, we run this, and remember, it sleeps for 3 seconds before it does anything. So look at that. Every 3 seconds, it says that it read a line, it was from client foo, and it said hello. That's great. Here's what we can do. I haven't showed this yet, but we can put an ampersand at the end of this command, and it will put it in the background. So remember how we controlled Z a program to put in the background? This is the same thing, but the program won't be frozen. It will be running. So that program's in the background and it is running. So every 3 seconds, it will write up here. We could put another program in the background. We could make another instance of this and call it bar. We could make another instance of this and call it Baz. Now we have 3 writers all writing up there and being read in there. So now we have 3 programs that are running in the background. We can run jobs to see them. We have job 1, job 2, and job 3. These are all running. So they will just continue to run and to continue to go there. And this will just happen forever until I kill them. So let's go ahead and do that. Let's kill %3. Let's kill %2. And let's kill %1. Now, if I hit enter, you can see a bunch of jobs terminated. They're all done. If I go up here and put a bunch of new lines, nothing else should get read. So yeah, that's a simple example. That shows the power of having one reader, but multiple writers. So you could have multiple things talking through this pipe, kind of signaling their progress if they were working on something. All right, so this is really cool. Let's back out of tmux and let's look at the final example here. We have something called all-in-one. There's a lot going on here, and I'm going to explain what's going on here. We are using a new built-in we have not seen before called exec. Exec can do a lot of things, okay? Exec can execute commands and make your shell become that command, but it also has this alternative syntax to open file descriptors. So I can do something like, hey, open file descriptor 3 for writing, and I want it to be dev null. So that way when I write to file descriptor 3, like echo hello, and write it into file descriptor 3, it goes directly to dev null. You can do that with exec. Now, instead of hard coding 3, we can use this syntax to store the file descriptor number in FD. We say, hey, open this, give me whatever file descriptor number you want, and I want to open this file for reading and writing. That's what the less than and the greater than's for. And the file we're opening is pipe, the FIFO that we created above. So now we go down here, let's ignore the function for now. We fork off a client foo, we fork off a client bar, we fork off a client baz. Very similar to what we did before. And then if we look up here in this function, the client is exactly the same. We take the name as the argument, we go into an infinite while loop, and we sleep for 3 seconds, and then we just write into that pipe. Now down here, here's the key. Remember that forever read where we wrap the whole thing in a while true? We don't need that down here because we're not putting the file name here. We're not doing this. We're actually telling read to read in from a file descriptor. Read takes an argument -u, which is a number of a file descriptor to read from. So we're not telling it, we're telling it, hey, you're not reading from standard input. You're not reading from a file. You're reading from this already open file descriptor. So it'll happily do this. This is all of the stuff we were doing in that last example, all in one script. So this script is basically talking to itself. It's forked off 3 children that are running in the background, and they're talking to that pipe. And as that data becomes available, it's there. So that pipe still exists in the file system, but it's open. It's an open file that exists in that program until I kill it with Control Z. And that's all there is to it. And then when you're done, you can clean up, you can just remove that pipe, and you're good to go. It's just a file that lives on your file system.